me hack an embedded device and kind of walk you through the process of what it means to hack an embedded device. I think a lot of people hear about IoT hacking all the time. I think that there's a lot of mysticism behind it where like people are like shooting up buzzers and getting things to like open up shells. There's a lot of that too. But there's also a lot of pretty simple exploits that you can just chain together and get remote code execution, which is why the talk's called Introduction to Vulnerability Chains, from process scripting to command injection. And it's presented by me, Ramgattie, and that's my Twitter handle between parentheses there. So, again, a little bit about myself. My name is Ramgattie. I like building and hacking web applications and reverse engineering mobile applications. There's a bunch of other things I do too. I reverse engineer DRMs as a hobby. It's kind of my fun thing that I like to do. I also get paid to do it as well, but in a different capacity. And I'm a senior security analyst at ISC. Since ISC paid for me to be here, I have to talk about them too. ISC is just a security consultancy. We're based out of Baltimore, Maryland, and sunny San Diego, California, where it is not snowing right now. And we do security assessments. We do all sorts of security assessments, and like most security consultancies, we do web apps, mobile apps. If like somebody wants us to look at their infrastructure, we'll do that. Native applications, kind of the normal gist that you'd expect from a security consultancy. And we do things from the white box perspective mostly. So I like reviewing the source code a lot. I like looking at protocols, that type of stuff. We do black box engagements as well, but we prefer white box because it's way more fun and all that. And if anything else, I heard somebody called an assessment red box one time, which was very confusing. And it was for a very different reason. And we do those as well, I guess. At the beginning of the presentation, I started talking about why I'm presenting, and that's because I work with the IoT Village. They're like a couple rooms over, and one of the things that I found out the most about the IoT Village is that when people come in, they think that they can't hack embedded devices because they don't have that like specific skill set. A lot of people think that it's like only about hardware hacking or something like that, which is really not true. A lot of these vulnerabilities are just like run-of-the-mill things that you run into. So for example, a lot of the vulnerabilities that sometimes people will find is just they like shoot off a Nessa scanner against some embedded devices, or just IoT devices. In this case, it's a NAS, and they'll find out like, oh, it's running a very old version of Samba. It has symlink traversal. What does that mean? And all of that. And the way that I do security assessments on embedded devices is a little bit different. I reverse engineer binaries and like find places where things are going wrong. So like it takes input and then it like passes it straight to a shell, and after bad things happen, which is what we're going to see. But I do more of that. I do the part of scientifically approaching something and like decompiling firmware and looking at what it's doing and what it's built out to find vulnerabilities. And that's kind of what our goal is going to be today. The device that I have here, I'm going to show you how we're going to find some vulnerabilities in my processes for finding them in a live demo, and hopefully it all works. And then after, I'm going to show why I'm picking those attack surfaces and discuss how we're going to go from, in reverse order, you would think it goes from command injection to process scripting, because we're going to find the vulnerability that I want to use, and then after find out what I need to use to make it remote. Here's the outline. So just the things that we just discussed. I'm going to be covering the Lenovo Ix4 300D, which is this device that's right next to me that I keep pointing to. We're going to be talking a little bit about the attack surfaces on the device. We're going to find the vulnerabilities together, and then after we're going to build the exploit. So the whole process is going to be dynamic. I have some things that are prepared in case something does mess up. Most of it is going to be you guys figuring out what it is that I do when I try to find these vulnerabilities in my day-to-day job. Here is the Lenovo Ix4. It is a NAS device that's made by Lenovo. It's now end of life, but they still, luckily for us, when we did find the vulnerabilities, we reported them to Lenovo. Even though the device is end of life, they did push out a firmware update for it. We had other manufacturers that when we found vulnerabilities and reported them to them as part of our research project, they didn't really care. They just said, all right, whatever, it's end of life. And we're like, well, there's a lot of these devices out there. And if it's end of life to them, it really doesn't matter anymore. Now, the discussion about the ethics behind it and all that belongs in other talks, so I'm not going to get into it. And so the way that you would interface with this device is that it runs over Ethernet, which is why I have to record here. It's connected directly to my laptop, and it allows me to get to the administrative panel on it and just like look at files and all the other things you expect to see in a NAS. When I started looking at the NAS, there were some things that I kept in mind. Some of them were internal threats. So threats to the house, like someone who's on the LAN, or somebody who already has access to other devices on that LAN. So think about it from the perspective of you use cross-site request forgery in someone's browser. That's, in theory, in the LAN, that's an internal threat because that's within, it's not from the outside world, it is inside. An external threat would be something where you can just hit this device from anywhere. So a lot of times I try to explain to people that even though you have the device on your network doesn't mean that it's not good, that it's not exposed to the internet. For example, port forwarding, it's a pretty common thing. A lot of people buy these devices instead of port forwarding because it makes sense because you want to get to your files from the outside world. That's why a lot of people set up routers with port forwarding as well, so that they can control who is on their network from anywhere. Sadly, that it's kind of ironic because setting up your router to have port forwarding accessible from anywhere tends to be the thing that allows attackers to get in. So we want a remote shell, and for that we're going to be using command injection. I've been throwing around command injection a lot. The idea is that sometimes the way that a application processes commands is that or processes some kind of functionality is that it'll take user input, pass it as a shell command for the OS, and then the OS interprets it and sends something back. That's pretty common with devices that are trying to reduce their footprint by not including a lot of applications. So if you have something that needs to ping somewhere and you're running the application for the device is running on a Linux device or Linux OS, it already has ping. Why install anything else? Just use the thing that's already there. But then after, if you don't sanitize that input correctly, you're in the problems. And then after custom scripting, which is a normal web application bug, it's probably one of the most common web app bugs, despite all the years that we put into it, even with templating engines, it's still pretty much a problem. So now that I've gone through all the boring stuff, let's look at just how I would find these vulnerabilities in this device. So I've already logged in, so let's go ahead and back out a little bit. So from my perspective, I bought this device. It's something that I want to audit. I already have the access to the username and password because I want to see what functionality is on the device and see how it all works. So just, oh wait, that's not projecting my screen. Sorry guys. So let's end share real quick. Maybe not real quick. So here we go. I'll log in again because I didn't realize it was not on that screen. Don't think the logging in matters all that much, but let's try it anyways. So just gonna log in. I have my credentials because I'm the owner of the device, and I'm the admin user. As you can see, if I zoom in a lot, there we go. Somebody chuckled, so I think somebody enjoyed it at least. And here we feed like all the features that it has. So there's a couple favorite features, and then there's this Lenovo device has a lot of stuff on it. So allows you to hook it up to S3. You can download other software. So this is pretty common with devices that you spend a lot of money on. They allow you to install other applications. I don't know if you guys have ever heard about Drogo or Synology or any of these other companies. That's pretty common with them too. So then after there's other functionality, so you can hook up Facebook if you want to. That's kind of strange. And there's functionality. There's one called security. And let's click on that. So when I saw this, the reason why I originally picked the security one because it'd be kind of funny for the presentation. And I saw that there was this thing at the top of the URL bar here, which I will send to Burp Suite coders so we can look at it together. And let's go to Burp Suite, into the coder. And so all it does here is that it takes a parameter called cat as a get request parameter, and it's set to all. So let's go to Firefox, and I want to look at where that is inside of the body of the page. I click on View Page Source, zoom in a bunch so you guys can see. And if I just look for all, it's going to show up a couple times. So that's going to be kind of hard. So let's try another one. Let's try CypherCon. Why did I open that? Let's try CypherCon. So if everything turns out well, and I zoom in here and look for CypherCon, there it is. So my input ended up straight up in the HTML. That usually sounds bad for those of you that do a lot of security stuff that involves web apps. I'm guessing that probably makes you think about cross-site scripting. So let's try to get that to work right now. So if I do a quotation mark to end this quotation mark here that I'm highlighting, and if I add another angle bracket, and let's try looking for CypherCon again. Zoom in. So it ended. Gosh darn it. So let's try looking at that again. We're going to do CypherCon, and we're going to do end quotation marks, add an angle bracket, and look for CypherCon within the body. We can see that it actually ended that A tag, and all the rest of the text was just left as garbage, which it's not good. So let's try something else now. Let's try closing that angle bracket, opening a new one with the word script. So that we're opening up a script tag, and we're going to set it to alert 1, script, and that should open up a script tag for us. So let's see if we can find CypherCon in here again, since that's the string that we're using. And our browser went through the DOM of the page and said, like, all right, cool, that's a script tag you included. So if we take this, and if we put it in the other window that we have, that's actually what's being displayed for us, that should open up a script tag. So step one, we got process scripting, but that's pretty easy. The thing that I want the most right now is that I want to, as an attacker, I want to have the ability to control this device from anywhere. And I found out that while I was going through everything, this personal cloud page had functionality to add another personal cloud. What this does is that it creates a directory on the device, and then after it sets it up so that you can share that directory with anybody on the internet. So we got a couple test inputs in here, and if we click apply, it's just going to remain processing. It's just going to throw a generic error. It doesn't know what to do. What I did find out is that when you issue that request, these are the parameters that are sent. So let's look at a repeater, which I hope is clear enough for you guys. I think that's a little small, so let's take a minute to close Burp Suite, and we'll open it back. Let's change the user settings so that we can see the display a little bit better. Change the font to something obnoxious, like 32. And close up Burp Suite, open it back up, and we'll see what we got now. So as we open that back up, the things that we just have in mind is that so far we found cross-site scripting, so whatever, if someone's logged in, what we can do is that we can send them a request, or just give them a URL that when they click on it, they're going to have arbitrary JavaScript evaluated in the browser. So now let's see, this is way clearer now. So these were the parameters that were sent when we issued that request. There's this C get request parameter, just URL parameter, that has this number in here. There's this cookie that's set to iOmega, because iOmega also makes the same device, it's just they brand it differently. This one's the Lenovo, the other one's the iOmega. And then after, there was all the test data that they sent in there. So there's a cloud name, username, password, and encryption. So there's like probably some things that are probably ringing for you. There's no way to, by default, this device doesn't use HTTPS, which in the grand scheme of things, probably doesn't matter to most users because they're probably using it internally, so they'll just wave it off as, all right, cool, there's no HTTPS, it's an accepted risk. I don't think it should be an accepted risk, but some people may consider it that. So one of the things that I did find out was that in one of these tabs, I have command injection. So it's the same parameters as you'll see here, but the password, when you set the password to whatever you want it to be, you can escape it with backticks and get it to evaluate shellcode. So now the code should be a lot more visible, and sadly it isn't, but I'll just move it back over so you guys can look at it. And this was all it was. So the part over here that I have highlighted shows, or part of what is highlighted here shows what's going to happen. So I escaped with backticks, which are just like, if you're familiar with bash syntax, you can just use backticks to evaluate commands instead of a command. It's pretty usual. Dollar signs and parentheses are pretty commonly used for those as well. Semicolons for terminating. So the sanitization routine for this would remove parentheses, it would remove dollar signs, it would remove semicolons, but it wouldn't remove backticks. So after listing all the things that I could use, I ended up going up with this. This netcat version is compiled with the -e option, which is deprecated for any of you that use Netcat nowadays. This is an older version of BusyBox. So this device, when I assessed that it was the newest firmware version of it, which is pretty recent, but a lot of these devices are just stripped down Linux, and instead they're like, oh, cool, we need all these Linux utilities. What do? We just include BusyBox, which if you work on an embedded device that's developed nowadays, you're probably going to run into BusyBox at some point. Just kind of how things work. It's a cheaper way to just like pass on a bunch of things together.
So that version actually has a version of Netcat with the Exe flag?
Can you say that again?
So that version of Netcat that's on that box
Yeah.
was actually compiled to have the Exe flag on there?
Yeah, it did have the TAC E flag on it, which is weird. It's like,
I guess doesn't hold that boxes, because I know they don't, that's a no-no.
yeah, that's like on a normal thing. It's like most of them are compiled with, or like they ship with a BusyBox versions that have Netcat with the -E flag enabled. So, as this gentleman may have pointed out, because he was excited about it, the -E flag means that whenever somebody connects to Netcat with this, or like in this case, when somebody connects to Netcat on port 9000, they'll be the binary that's going to be evaluated is going to be /bin/sh, so that as soon as that happens, you're dropped into a shell. So I'm going to remove this here because it's going to mess up everything. But if we issue this request, and if everything went well, I should be able to just connect. I'm going to zoom in a lot so you guys can see this too. And there we go. And you still can't see that. How about now? Yeah, that's good enough. So that's in the one in the middle there. So if we go to the device, it's at 192.168.2.6, as it says here in my browser, or as it says here in the personal cloud stuff. Here's the host. So if we connect to the device at 192.168.2.6, and the port was 9000, and we type in ID, we're root. Which is pretty well, because that was not very hard. But there are some parts of the request that really matter, and that's what I want to get to next. So you can issue a post request, which you can get through CSRF, and you only have to set the password to that Netcat, the Netcat command that I had between backticks. So it really isn't that bad. There are some parts of this that matter though. I can't issue this request without this iOmega cookie option and this C one in the URL. So the first thing that I thought is like, all right, cool, I could probably use cross-site scripting to just get this iOmega cookie, but there's a problem. The iOmega cookie is set with the HTTP only option. So that means that even if I have cross-site scripting, I can't pull that cookie out. This cookie, however, or this value, we're going to call it a cookie because, or let's call it session token. That's probably way better. That session token in the URL though isn't set with that option, and it's a post request. So that means that I can issue the request with like cross origin. So if we combine all those things together through CSRF, we can issue the request, and the browser will automatically send the iOmega cookie value, but we won't be able to get this one. But because I have cross-site scripting in another page, I can use the cross-site scripting to pull the value out of the browser's local storage. So let's go back to Firefox and see if I remember how to go to local storage, web developer console. And in storage, in local storage, the iOmega user cookie is set there, which is that 6.7 value. So it is really tiny. And I'll just copy it over. Here's where you guys can see it. Move these together. So this was the value that we saw before, and this value is the one that we saw in the URL. With cross-site scripting, we can get that value. So let's see what that looks like. For this part, I am going to kill the listener that we just had where we found out we had root. I'm going to go to my desktop, and I'm going to go to demos. And I'll open the one that I did at the most recent presentation, which was at the site San Francisco. And here we see that we just normal script with very funky colors. And you'll see that first thing I do is create an XML HTTP request. I use const because I know how to use JavaScript, unlike most people. And then after I look in local storage and I get the item called iOmega user cookie, which is what I found out before. So for some reason, when they developed this device, they call the value that they put in the URL the user cookie. Although that's not what cookies are, because there's a cookie header section according to the HTTP RFC. but they didn't follow it. Then after the URL is the URL of that value or the functionality that we want to look at. So that's the functionality. So it says CP personal cloud login and then the value in the seat and between the string interpolation. And that's, if we look at the one I was looking at Burp Suite, that's what this URL is as well. It's personal cloud and then the C option here. We're going to place that value inside of that URL. We're going to send a parameter where we're setting the body of the request to these options here, which is just the same netcat listener we saw before. We're going to issue a post request, and it should be automatically sent. So the trick is that we have to have in mind that the only way that this is going to work is because that HTTP only flag is set on that cookie, but there's nothing stopping us from issuing a cross-origin request because it's a post request. There are other cookies, like for example, nowadays Google has that same site cookie that would stop this, but it wouldn't matter for the specific case because it wasn't set with the same site cookie. So if we go back here and we build I need to go back here. I need to set up a Python simple HTTP server so that I can get the value. Simple HTTP server. And I know the name of the file is this one that I want. We'll go here, we'll set up a script tag where the source is going to be the art listener, so it's going to be http://192.168.2.1, port 8000, and then after I'm going to get that file, and if we close that up, close that script tag, everything should be fine and dandy. We issue that request, and this was in the wrong page. I need to send it in the security page, which is the one that has process scripting in it. So let's go back over there now. Make sure that Burp Suite is not intercepting our request, and it totally is. We'll go to the security page, and after we hit the security page, we'll be able to set the cat parameter to what we want it to be, which is that script. If everything went well, our listener, so the listener that I set did get the file. Process scripting should have worked. So if I kill this listener right now, and if I were to log into the device on port 9, or try to connect to the device on port 9000, there is 0 credentials being used anywhere, just using netcat. If I type in ID, that was a full exploit. So I just combined 3 things. I combined the process scripting with the cross-site request forwarding to the command injection, and now I can just give anybody who has one of these devices this URL right here, which I'll put somewhere else for you. Open it here. So that's the one URL I need to give to anybody with one of these Lenovo devices to fully compromise their device. The device is running, so the web, for those of you that were paying attention, the web server was running as root. So that means that we also will be running everything that all of our access will also be that of the root user. Funnily enough, when I got the device, it prohibits you from being the root user and interacting with the device. But if you were to exploit it, you have the ability to do so. That's kind of a common thing where a lot of these devices are sandboxed to prevent you from being the root user so that you can modify the firmware or extract it. But if an attacker were to hack you, they would have more access than you would to your own device, which is funny yet terrifying. So that's kind of the gist of what I wanted to show you guys. So it's kind of like building that up together and like running through the motions of trying to debug, why is this not working? What are the things that I need to figure out to make this a fully remote exploit? I am a couple minutes early, or many minutes early, I think. And so I'm now here for questions. Do any of you have any questions to do with the hand risen up?
Question. So you did that while being logged in.
Yes.
Can you execute all the steps of the exploit without being logged in?
Yes.
Okay. Awesome.
So the victim, so the URL itself would have to be given to a victim that's authenticated because it is CSRF. I'd still need them to be logged in order for it to work.
So you have to fish someone.
Yeah, you would have to fish somebody, and you would have to make sure that they were logged in while they're being fished.
Okay.
Yeah. Other guy with his hand up.
How long did it actually take you to discover this in like real work time?
So it took me 8 hours, and I did it the week before DEF CON because we had a bet going on, And the bet was that I couldn't double the amount of vulnerabilities. So the previous year, the team found 52 vulnerabilities. I was very cocky and I said that I could find double that. And I didn't have enough, so I had to go buy this device to try to find vulnerabilities. It was a rush thing. It usually takes more than 8 hours. Yeah. Anybody else? Alrighty then, thanks folks. Hope you enjoyed the presentation.